So let's take a look at number 1. So we have to use log base 5 of 3 and log base 5 of 6 to evaluate the logarithm. So we've actually seen this question in our homework before. How can I get 2 out of using 6 and 3? Six divided by 3. So this is log base 5 of 6 divided by 3. Bless you. Now if I'm expanding this, what goes with division? Subtraction. So this is log base 5 of 6 minus log base 5 of 3. So we're going to use the numbers that it gives us. Log base 5 of 6 is 1.113 minus log base 5 of 3 is 0.683. So we just plug these into our calculator.
That would be 0.43.
So we get 0.43. All right, let's look at number 4. So here we're expanding the logarithm. So what's happening between the 12 and the x to the 7th power? Multiplication. So if I were to expand this, what goes with multiplication? Addition. So I start with log base 3 of 12 plus what? Log base 3 of x to the 7th. So every time we split it up, each one needs its own log. So that x to the 7th power needs a log with it. Now I can expand this a little bit more. What do I do when I have an exponent? Move it to the front.
Which would give you log 3 of 12 plus 7 log 3x.
Awesome. Log base 3 of 12 plus 7 times log base 3 of x. So any exponent, you move it in front of that log. All right, let's do number 10. So here I'm condensing it. So ln's work the same as logs. So if I'm adding my ln's together, well, first I have to get rid of the coefficients. How would I get rid of those two coefficients? Make them exponents. So I bring it to the top. So I do the opposite of what I just did when expanding it. So this is ln of x to the 3rd power plus ln of y to the 9th. So if you have a coefficient in front of that ln, just make it the exponent on your variable or on the number. Now what goes with addition? Multiplication. So how would I write my answer? X to the 3 and y to the 9, that's it? With an ln on the outside. So when you're condensing it, you're just condensing it down to one ln, but don't forget that ln in your answer, or the log. But you get rid of the other one. So you're condensing it down to just one ln in your answer. All right, for number 12, we have to use the change of base formula to evaluate. So what's my change of base formula? What would I do here? The division. So which one goes on top? So log of 3 over what? Log of 5. Both of them get a log. And don't forget, the base goes on the bottom. So in my calculator, I'm going to do log of 3 divided by log of 5. Make sure you know how to use your own calculator. Every calculator is a little bit different, so you may put it in differently. So you should get 0.6826, but if we're rounding to 3 decimals, does the 6 mean that I round up or keep it the same? Round up, so 0.683. So 6.6 for 1 through 6, like these first 4 examples here, they're super similar to the ones that we did in the notes. I don't want to do them all for you because I do want you guys to practice some. We can do 4. How would I do number 4? So remember, if we have the same, so let's look at one real quick. If we have the same base, what could I do? I can just cancel them, and set the exponents equal to each other. But could I make 13 have a base of 6? Could I make 13 6 to some exponent? No. So what do I do if I can't make them have the same base? Log base what? Log base 6. Perfect. Whatever the number is that has the exponent, that is our base. So log base 6 on both sides. Whatever we do on one side, you have to do to the other side. So on the left side, what happens? Log base 6 of 6 cancels, and we're just left with 4x. On the right side, what would I do with log base 6 of 13? How do I put it in the calculator? Change of base. So log of what on top? Log of 13 over log of 6. Perfect. Here we have to do the change of base to put it in the calculator. So log of 13 divided by log of 6. We get 4x is equal to 1.432. Keep it in your calculator. That way you don't end up rounding twice. Just keep that number in your calculator. What's the last step that I have to do? Divide by 4. Awesome. So we just click divided by 4 in the calculator. We get 0.3578. That 8, does that mean we round up or keep it the same? Round up. So 0.358. Let's take a look at 8. So what do I do for 8? If I have an ln is equal to an ln. I can cross them out. So then I set the insides equal to each other. So 3x minus 8 is equal to x plus 6. And then from here we just solve for x like we normally do. What would I do first?
Cancel out x, cancel out 8.
How?
Add 8, subtract x.
I can add 8 to move it to the other side and subtract x. Awesome.
So it would be x equals 14.
So 2x.
Oh, 2x equals 14.
Gotta be careful. So 2x is equal to 14. Divide by 2, so x is equal to 7. Uh-huh. Let's take a look at 14 or 16. Which one? 14. All right. So if I have 2 logs on one side, what do I need to do? Combine them. I need to condense it to 1 log. So we did a couple of these in the notes yesterday. Condense to 1 log. When I'm adding, how do I condense these together? Multiply. So we get log base 2 of x times x minus 3 is equal to 2. So all I did here was condense. I'm going to write it on the side here so we have more room. What should I do next? Awesome, I can multiply inside the parentheses. So I have to distribute that x. So I have log base 2 of what? X squared minus 3x. Perfect. All right, now my goal is to get rid of that log. So what do I have to do to get rid of the log? So I'm canceling it out. How, Luca? So because my little base is 2, I got to make the big base 2. So this is 2 to the power of log base 2. What happens on the left side? It cancels. So I'm just left with x squared minus 3x. And then that's 2 to the second power. So this is an exponent. So 2 squared is what? 4. All right, our favorite part that we know and love when we have x squared and x. What do we have to do, Gabby? Factor. So if we're gonna factor, it has to be equal to 0. Awesome, Jordan. We move the 4. So x squared minus 3x minus 4 is equal to 0. So do we have two factors of negative 4 that add to negative 3? Negative 4 and 1. So x minus 4 and x plus 1 is equal to 0. So what does x equal? So set them both equal to 0. So we just flip the sign. So x is equal to positive 4 and x is equal to negative 1. What do I do when I have two answers? Check. What can I not have the log of? A negative. So if I plugged in 4 into my x's here, could I take the log of 4? Yeah. Could I take the log of 4 minus 3, which is 1? Yeah. So 4 works. Let's try, what was the other one, negative 1? If it's negative, it doesn't work. So if it's positive, it works. Can I take the log of negative 1? No, because we can't take the log of a negative. So negative 1 does not work. Remember, we cannot take the log of a negative. No, ln's the same thing. You can't take the ln of a negative number. So my only answer here is x is equal to 4. So if you get two answers, you have to check. You just can't take the log of a negative. So when you plug it in, you don't have to work it out. Just plug it in and see, I have the log of negative 1. That does not work. So our only answer is 4. So for 16, what would I do first? So I have to condense it to 1 ln. How? I multiply. So the ln of x times x plus 4 is equal to 3. How can I get rid of the ln? Ln is log with what base? Log base e. So what do I need to make my big base? E. So make the big base e on both sides. So it cancels out here. So we're left with x times x plus 4 is equal to e to the third power. I'm pretty sure this one doesn't factor, so just let me double check the answer, but you guys can stop here. So this one you don't need to finish. Just it's important to know that ln is log base e. So ln is the same thing as saying log with base e. All right, so do the rest of it on your own. Use this time, get it done. Ask me questions. If you don't understand anything, this is the time to ask questions. 14, guys, so like the very end of the page. So there's another 14 below it. This 14 you can skip to because it's the same. So you can skip the 14 at the bottom too.